Have you ever looked up at the night sky and wondered why some planets seem so lonely? I mean, think about it. Among the 8 major planets in our solar system, Earth has its beautiful moon, Mars has 2 tiny ones, Jupiter has over 90, Saturn boasts an incredible 274, Uranus has 29, and Neptune has 14. Even the dwarf planet Pluto has 5 moons of its own. But then there are Mercury and Venus, the 2 planets closest to the Sun, and they have 0. Nothing. Why are they the odd ones out in this big cosmic family? Were their moons swallowed by the Sun? And here's a wild thought. If we moved Earth and our moon into Venus's orbit, would the moon survive, or would it be torn apart? Today, we're going to unravel this fascinating mystery. First things first. To understand why Mercury and Venus are moonless, we need to know how moons are born in the first place. Generally, there are 3 main ways this happens. The first is called co-formation. Imagine a young star surrounded by a massive disk of gas and dust. As a planet forms within this disk, some of the nearby material can clump together at the same time, eventually creating moons. These moons tend to have nice, stable orbits and circle the planet in the same direction it spins. Jupiter's major moons, like Ganymede and Callisto, and Saturn's giant moon Titan, are classic examples of this process. The second method is gravitational capture. Sometimes, a passing asteroid or a small celestial body gets a little too close to a big planet. The planet's powerful gravity can grab it and pull it into orbit, turning it into a new moon. A perfect example of this is Neptune's largest moon, Triton. What's really interesting about Triton is that it orbits backward against Neptune's rotation. This retrograde orbit is a dead giveaway that it was captured from somewhere else in the solar system. And the third way? Well, it's a bit more dramatic. A giant impact. This is how we got our very own moon. By studying the chemical makeup of rocks from the moon and Earth, scientists have found they share a clear family connection. In fact, in late 2023, a groundbreaking paper in the journal Nature announced the discovery of a huge, mysterious blob deep inside Earth. This anomaly is believed to be a remnant from a colossal collision that happened about 4.5 billion years ago. Back then, our young Earth smashed into a Mars-sized object named Theia. The impact was so violent that it blasted enormous amounts of molten rock into space. Over a very long time, this debris clumped together and eventually formed the moon we see today. So, in a way, our moon is the beautiful result of a cosmic car crash. So, let's get back to our moonless planets. Why doesn't Mercury have a moon? Is it just too small? Well, we know Mercury is the closest planet to the Sun, orbiting at a distance of about 36 million miles. It turns out there are 3 key reasons why it just can't hold on to a moon. First and foremost is the Sun's overwhelming gravitational pull. The Sun's gravity on any object near Mercury is way stronger than Mercury's own gravity. So, if a moon tried to orbit Mercury, the Sun would easily snatch it away. It's like trying to have a quiet conversation next to a jet engine. The Sun's gravity just drowns everything else out. Second, Mercury's own gravity is pretty weak. Every planet has something called a Hill sphere. You can think of it as the planet's personal space, the zone where its own gravity is dominant. For a moon to have a stable orbit, it has to stay within this sphere. If it wanders outside, it gets captured by the sunday. Because Mercury is so small, its Hill sphere is tiny, only about 70,000 miles in radius. That's much smaller than any other major planets. And third, there's a deadly combination of 2 other cosmic limits. A moon orbiting too close to a planet gets torn apart by tidal forces. This no-go zone is called the Roche limit. For Mercury, the Roche limit is only about 4,000 to 5,000 miles above its surface. So, you have this incredibly narrow window for a moon to exist. It has to be far enough away to not get shredded, but close enough to stay within that tiny 70,000-mile Hill sphere. There's almost no stable space in between. Even if a moon magically appeared in this sliver of an orbit, the Sun's constant gravitational tugs would destabilize it within a few thousand years. sending it either crashing into Mercury or getting flung out into space. Okay, but what about Venus? It's much farther from the Sun, so what's its excuse? The most widely accepted theory is that Venus probably did have a moon once, but a series of very unusual events led to its disappearance. First, it's likely that Venus, like Earth, formed a moon from a giant impact early in the solar system's history. So, it wasn't always alone. But then, something strange happened. Venus spins backward. It's one of the few planets with a retrograde rotation, meaning it spins in the opposite direction to most other planets. This bizarre spin was probably caused by another massive collision billions of years ago. So, how does spinning backward make you lose a moon? Well, if a moon orbits in the opposite direction of its planet's rotation, tidal forces act like a brake. They constantly drain the moon's orbital energy, causing it to spiral slowly inward, closer and closer to the planet. Eventually, it crosses the Roche limit and gets torn to shreds. Neptune's moon Triton, which we mentioned earlier, is facing this exact fate. Because it has a retrograde orbit, it's slowly spiraling toward Neptune and is expected to break apart millions of years from now. It's very likely that Venus's original moon met this same demise, spiraling inward until it was completely destroyed. Now for the really mind-bending question. What if we took our Earth-Moon system and plopped it right into Venus orbit? Would our moon survive? Scientists have run detailed simulations to find out. According to their models, if Earth were in Venus's orbit and started with a faster rotation, say a 12-hour day, the Sun's powerful gravity would immediately start to wreak havoc. Solar tides would relentlessly slow down Earth's rotation. In less than 500 million years, our 12-hour day would stretch to a sluggish 72 hours. After another 500 million years, things get even worse. The tidal forces would actually reverse. Instead of pushing the moon away, which is what's happening now, they would start to pull it in. The moon's orbit would begin to tighten like a slowly winding spring. Eventually, inevitably, the moon would cross Earth's Roche limit. At that point, it would be torn apart by our planet's gravity, shattering into countless pieces. Earth would suddenly have a bright, brilliant ring system, just like Saturn. But it would be a bittersweet sight. Being so close to the Sun, Earth's magnetic field would weaken, our oceans would boil away, and our world would become a barren, lifeless rock with no moon and no water. So, the reason Mercury and Venus are cosmic loners isn't because the Sun got hungry and ate their moons. It's all about their unique circumstances, their orbits, their gravitational environments, and in Venus's case, its peculiar rotation. Being too close to the Sun shrinks a planet's stable zone for moons down to almost nothing. Any moon that dares to enter this zone risks being shredded by tides or stolen by the Sunday. And for Venus, a backward spin may have spelled doom for any moon it once had, pulling it in for a slow, destructive dance. These special cases give us a glimpse into the chaotic and violent early days of our solar system. They remind us that not all planets get to keep their companions through billions of years of evolution. The fact that our moon has stayed with us for so long is actually quite rare and precious. So, while making a moon might be common in the universe, whether a planet gets to keep it depends on a delicate balance of mass, gravity, distance from its star, and even its spin. Not every planet is lucky enough to have a friend lighting up its night sky. Thanks for watching, and if you enjoyed this journey through the cosmos, don't forget to like and subscribe for more deep dives into the wonders of our universe.